In this example, we look at one of our clients where we tie into their existing HVAC, their existing Wi-Fi, their existing audiovisual, their existing sensors in the room for CO2 monitoring, and use all of that data to make comparisons. And those comparisons can tell us a story of what's happening in that space. That story can then lend itself to how do we design future spaces, how do we operate this space more efficiently, what automation can we apply, and we can even simulate that automation before we apply it. We talk about all those things in this video. When you're looking at space, this is telling us the huge difference in this case between expected attendees and occupancy and real-time attendees and occupancy. And with the university timetable systems in particular, they're making educated guesses based on the class sizes and the available space, and it's not taking into account real-time data. In corporate real estate, it's a little bit different if you're using like Office 365 and you're inviting attendees, so you sort of know that there's 6 people in the meeting, maybe 3 of them will turn up. The disparity isn't as big. But this is a great starting point to start thinking about, well, if we look at the difference there, what can we start stacking on top? What other data sources can tell us what's happening in that space versus what we expected to happen in that space? Because if we're running all of our planning based on this false information that these people didn't actually turn up, and if you're running your planning on the scheduled data, then you're going to be just running systems incorrectly. Everything from HVAC to access and security systems, and any space planning you're doing based on this data, even the size of real estate that you need, might be able to downsize if you look at the real-time data, not the scheduled data. So what else can we add to this, knowing that there's a disconnect between expected occupancy and real-time occupancy? Well, other real-time sources can paint an even better picture, and we can start to put in thresholds and work out how do we operate this more efficiently. So PlaceOS allows you to integrate with air quality sensing. We can look at the humidity levels. We can look at the CO2 parts per million, the temperature. Is there a class in progress right now? So that could be useful for knowing how attendance affects these real-time data sources. And then we look at this over time, and we can start to look at these patterns and set different thresholds based on the historic usage. So we connect to so much data that it's highly configurable. So we have integration drivers that manage the communication between each of these systems, giving us this data. And then we store that in a time series database, and you can pull up any of these data sources within your visualization tools. So that's useful. So we can start to work out what's happening in the class, to start to go further and work out what automation can we add to improve the operation of this space. In this case, a teaching space, a lecture theatre. How do we know if the room is occupied in real time? There's a number of sources that we can use, all existing in the space. There wasn't anything new that we added. We retrofitted into the space, and we could access the lighting network, which gives us the PIR sensor, and the Wi-Fi network, which gives us the number of mobile devices on the Wi-Fi network. So using those two things, we can work out if the space is occupied. And that's how we have the real-time data that we can compare with the scheduled information and the expected occupancy of the scheduled information. So it's not just a binary, was the room booked and no one turned up? It could be, was the room booked and how many people turned up versus how many people were expected, and perhaps they didn't need this large lecture theatre. Here's where it gets really interesting. So with all this data coming from PlaceOS, we can actually run automation simulations. So we can look at the operation and the expected operation and look at areas where there could be potential efficiencies and cost savings. So we did exactly that for the utilization of the space and looking at when the air conditioning was on, or in their case, the heating, which is even more of a culprit for energy consumption. So the heating was on, but there was nobody in the space. So we could see that disconnect through this particular graph, where one line represented, is anyone in the space, and the other line represented, was the HVAC on? And when we literally see a gap between those lines, there's opportunity for automation. So you can run that in simulation mode as long as you want to start to see the potential cost savings and benefits of applying that automation, which you then go into PlaceOS back office and add that trigger to indeed turn off the HVAC when there's no one in the space. So this graph for the client, we're looking at other things we can reference. So an interesting thing to reference that you don't see very often because these systems are usually separated, but PlaceOS brings them together, is Wi-Fi usage and CO2 levels. So there's a correlation. When there's more Wi-Fi devices on the network, we see the CO2 levels go up because generally there's more people in the space. But there's outlier events too. There's an example in this graph where there is no event in the timetable system. We don't see any Wi-Fi devices on the network, but the CO2 levels are actually increasing. The highest it is over those 2 days that this graph is showing. So those outlier events are what you should be investigating. So that could be something we can look, is there other systems to give us some context on what's going on there? What is the access control system telling us? Is the room unlocked and maybe the doors are open and there's some pollution, or there could be any number of reasons the CO2 is going up without people in the space, or perhaps people are in the space without being on the network. That's another possibility where you might want to depend on additional real-time location sources such as cameras and other systems that can tell you and always paint a better picture by stacking these things up.